Hey guys, so we're going to practice systems word problems today using what we call UPSC. Basically, when you guys see word problems, I know a lot of you guys just don't know where to even start. So UPSC stands for understand, plan, solve, check. It's basically just a process to help you think through the problem. I'm going to do number 1 with you guys, and then you're going to do 2, 3, 4 on your own. So let's go ahead and read through number 1. A bus travels 2 different routes, the green route and the blue route. The routes are different lengths. On Monday, the bus travels green route 6 times and the blue route 5 times, traveling a total of 52 miles. As I'm reading through the problem, anything where I see a number, I might kind of keep track of. So green route 6 times, blue route 5 times, and then the total is going to be 52 miles. Okay, that was just Monday. So Tuesday, the bus traveled the green route 12 times and the blue route 13 times. So let's go ahead and underline those for a total of 119 miles. Okay, so hopefully you can see, remember, system is when we have 2 equations and we look for where they cross. We've got a Monday equation and we've got a Tuesday equation. So understand is writing down what the problem wants you to do. So if I keep reading, it says, what is the length of the green route? So we are specifically going to find the green route. All right, so understand. We want the length, which if you look over here, we're talking about miles. So when we say length, I'm talking about a number of miles of the green route. Okay, so when I answer my question in a minute, I'm going to make sure, did I actually get the right route? Okay, plan, define variables. So this is where if I'm going to use x in an equation, I want to know what x stands for. So just to keep it in the same order of the problem, I'm going to say that x is the green route. And again, it's going to stand for the number of miles. And y is going to be the blue route. Oops. Okay. Now, we can actually make our 2 equations here as well based on the information the problem gave us, because plan is kind of getting all the information figured out, and then solve is where I'll do all the actual calculator stuff. Okay, so for Monday, we said 6 times on the green route, so 6, and then the miles for that was x. I'm going to do 6 times x. Blue route was 5 times, and that was y, so I'm going to do 5 times y. Total means you're going to add the 2 routes together, and we're going to get our 52 miles total. Okay, so that was Monday. Do the same thing for Tuesday. So I'm going to have 12 times x for green, 13 times y for blue. I'm going to add those together and get my total of 119 miles. Okay, so that's everything the problem gave me, kind of just transformed into equations. For solve, we're going to go ahead and actually do this in the calculator, but I can't plug these into y equals until I've solved for y, and this is the worst of the problems I've given you today, so thankfully we're going to have to do this one time from start to finish, but let's go ahead and do it together. So I'm going to rewrite my equations real quick, kind of give myself space to do both. So solving for y, we always move our x term first, so I'm going to subtract 6x from both sides. First thing I want to say is if I ever go through any of this stuff too fast on the video, you're welcome to pause it, replay it, do whatever you need to do. Okay, so if I keep going, 5y is going to equal negative 6x plus 52. And then I can divide everything by 5. Okay. So I've got y equals, now negative 6 over 5, you can get a decimal for, but all I really care about is that y is by itself. So the calculator can handle fractions. I'm not going to make that more complicated on myself. I'm just going to leave it as a fraction. Okay, and that is going to be the equation that I plug in for y1 in a moment. We'll go to the calculator and plug that in. Okay, let's do the same thing over here, though, for y2. Now, hopefully you're starting to notice, as we've done this over and over and over again, it's the exact same steps, just with different numbers. So over here, I move the x term first. I'm going to do the same thing over here with 12x. I'm going to subtract 12x from both sides. So that's gone. So 13y equals negative 12x plus 119. Divide everything by 13. So y equals, again, I'm not going to deal with making those into decimals. I'm just going to leave it as a fraction, and we can plug it into the calculator as a fraction. So this is going to be what I plug in to y2. Okay, so let's go ahead and grab your calculator. We did this yesterday. We're going to do it again. Honestly, I recommend clearing your memory before you do anything. Remember, it's second plus 7, 1, 2, just to kind of clear out any weirdness from the last period. Okay, y equals. Type in your equations. You'll use your alpha y equals to get these fractions in there. That's why we don't care about fractions, because the calculator can do it. Okay, so y1, and then y2 was our negative 12 over 13x plus 119 over 13. Okay, I would just take a quick second to make sure you didn't type anything in funny. It's always a good thing to check because it's just going to cause more chaos in a moment. All right, I like to push graph first to see if I can actually see the intersection. Sometimes we have to mess with that window if we can't see it. Oh, good, we can see it. Okay, so this is where we go to second trace or second calc, and then we went number 5 for intersect. And then if you don't see your spider, you can always use these numbers to kind of help you. X equals 0 means it's like up here somewhere, so I'm just going to push right until it starts showing up. There it is. You just want to get it as close to the intersection as you can. Enter, enter, enter until it says intersection. So the answer I got was 4.5 for X and 5 for Y. Okay, now one thing you can do is use your answer choices, but specifically, does this make sense? Is it logical? Yes, since these both stand for miles, it makes sense that they're positive numbers. It wouldn't make sense to have negative miles. And then does your answer cover everything? We've got to make sure we actually answer the question. We just wanted green route. Think back to how we recognized that. We said the X was green route. So up here, I could have even said we are trying to find X specifically. So we just care about this number. So our answer is going to be 4.5 miles. Okay, thankfully I wasn't too tricky. I didn't put 5 as one of the answer choices, but I've seen them do that. So be very careful that you look at the right one. Our answer is going to be B. Okay, that's it. One thing I want to say about the other problems, 2 and 3, you can kind of see them here. 2 and 3, look at the answer choices. They're specifically just having you set up the problems, not actually having to solve, so it should not take as much time as this one. So when it says write down what the problem wants you to do, you're just going to set up the system. You do not have to solve. So you're not actually going to end up using your calculator on 2 and 3. And also to help, because some of these are a little bit trickier than the first one, I've given you some kind of guided fill in the blanks to help you understand all the stuff in the problem. But really I want to emphasize, use your answer choices to kind of narrow down things as you figure stuff out. Same thing on 3. That one's probably a little bit easier. And then 4, I give you as little information as possible. So I really want you to go like step by step through the whole problem. You are going to have to solve on this one. You see there's actual numbers, not just equations. I did give you a hint when you get to the equations. You are going to have to change your window, so make sure you do that. But that's it. So you've got 30 minutes for this whole period to get these 4 done. If you need help, please ask. All right, good luck.